Hello, my name is Evan and I work at Samsung Research in Samsung Electronics Seoul, Korea. I'm going to explain what secure volume hot plugging for containers technology is in this session. Container has been a very popular virtualization model. Its super easy and fast deployment nature meets rapidly changing organization needs. Tons of technology in artificial intelligence and data science come to the office in every single morning. So we have built our data science platform on top of container infrastructure. The first goal we wanted to achieve was to move local development environment based on Jupyter Notebook to our on-premise cloud. Jupyter Notebook is a kind of IDE. Users access the terminal, create documents, execute the code, and save lots of figures, images, and medias inside the applications. Second goal was to provide exactly same interface that was based on POSIX file system API. Users had already made lots of works on their local computers. When we migrated those work environments to the cloud due to the data management issues, we didn't want to restart those works from scratch with cloud-friendly interfaces such as AWS S3 interface. To support POSIX file system API, firstly, you have to mount a storage to the application. Here's an example of Kubernetes. Kubernetes is a container orchestration engine that creates containers on multiple server hosts. The volume should be configured in a container specification for the stateful application that has its unique persistent layer. We use the safe file system on our infrastructure. In Kubernetes, you can directly send this declarative specification to the API server. Then Kubernetes creates a container matching to the specification including volume configurations, and you can now access the volume using POSIX file system API. What if you need a dataset stored in another volume? Let's use Container Engine API again. Add a volume configuration to this container specification. The running container is terminated by Kubernetes and restarted with the changed volume hierarchy because container configuration is immutable and declarative. This is good for stateless applications. However, user would experience the application downtime and lose all data in memory in a stateful application such as Jupyter Notebooks, TEIA like IDE applications. What about this approach where you mount a new volume inside the application? This would work in the virtual machine like AWS EC2, and that's why many users had requested this kind of user experience. But it doesn't work as we expected inside the container. Mount operation requires root per user permission and sysadmin Linux capability. Both of them are not easily allowed in most distributions of container systems. What about us? Should we give such privileges to the application? No, I don't think so. Why not? Let's see the vulnerable nature of container architecture. Here are three containers running on the same host. They all share the same host kernel, and that is main difference of container virtualization model compared to virtual machine virtualization model, where all virtualized environments embed guest kernels. Before we give such privileges to the container, we can see that all devices nodes are isolated and protected inside the container. However, all host devices are exposed to the privileged containers. In other words, users can access the privileged containers and manipulate the host kernel data structures hardware resources, and the vulnerability can be propagated to the other containers running on the same host. That's why we cannot grant mount operations on users' containers. We addressed this vulnerability by supporting volume mount operation in volume hot plugging sidecar. Sidecar pattern is a structural pattern introduced in Hot Cloud 16. A sidecar is a container deployed in the same host where the main container is running, and it provides additional functionalities without changing the main container. Applying this sidecar pattern, we wanted to add dynamic mount functionality in runtime through volume hot plugging sidecar without any change of the main application. Let's see how volume hot plugging sidecar provides those functionalities from its architecture. We give a required privilege for mounting operation only to the volume hot plugging sidecar container. User only accesses the application, and container's isolated environment can protect the sidecar container from user access. And secondly, creates an ephemeral volume that is shared by both the application and VHP sidecar containers. The ephemeral volume is a temporal volume that has same life cycle with both containers. We're going to use this volume as a parent directory where volumes are dynamically added. Now, let's mount a new volume inside the sidecar. Unfortunately, the mounted volume is only visible inside the VHP sidecar, but not in the application. The secret was mount propagation. When a container is created, resources in the container are isolated by Linux namespaces such as network namespace, process namespace, and mount namespace. Mount operation is one of operations protected by mount namespace. Instead, mount operation provides its sharing properties through mount propagation options. By default, it is none, and all changes on the mount namespace are fully isolated from other mount namespaces. That's why the change of sidecar mount table did not change the application's mount table. So we set the ephemeral volume mount option of sidecar container to the bidirectional, so that the host mount namespace can be synchronized whenever sidecar container mount table is changed. Bidirectional option requires a special privilege because it actually changes the host. But it is not the case since we already gave special privileges to the sidecar container. To the application container, we set the mount propagation option to host to container instead of giving privileges to the application container. As we wanted to propagate mount table change from sidecar container to the application container in a single direction, this option enables it by propagating the change from sidecar to the host and from the host to the application in sequence. The final architecture of the application would be like this. By deploying the application with this architecture, you can dynamically mount a new volume to the application container without restarting the application or taking a security hole. We have achieved 530 milliseconds latency of mounting volumes to the application, and that is much better than restarting the application. In our paper, we also deal with answers about some questions like how to safely provide an automated volume hot plugging interface to users, and some issues raised by introducing such privileges VHP sidecar containers to the infrastructure. Thank you for watching this video.